Hello everyone, I am Darsh. This is Agility Tech, and today I want to walk you through something that I've been building on and that I'm genuinely excited about. A system that watches how a business makes its everyday decision, learns from every single one of them, and starts making better decisions on its own every day without anyone babysitting it. So now stick with me here because I know AI decision making sounds like one of those buzzwords everyone keeps throwing around these days. So let me set the scene here with something real first. So think about any business that runs on repeated decisions, how much inventory to reorder, what discount to slap on a product before it turns into dead stock, and how much to purchase from a supplier given the lead time. These aren't one-time decisions, they happen every single day for every single product forever. And who makes these calls usually? It's a person with years of experience going mostly on gut feeling. Yeah, like this item usually needs about 500 units around this time of the year, and that gut feeling is genuinely valuable. The problem is, however, it lives inside entirely inside that person's head, and it's never captured anywhere in a form that the business can actually learn from or improve on. So every time a new person takes over, or the market shifts, or 100 small edge cases piles up over the years, that hard-earned judgment doesn't compound; it just resets. So here's the question with I started with. What if instead of losing all that judgment, we could actually teach a machine to learn it, not by watching someone else making decisions, which is slow and risky and takes thousands of years, but by actually looking backward at years of decisions that actually already happened and the outcomes those decisions actually produce. So, what if I told you this system doesn't just learn from that history once and call it done? It actually runs every single day in production, recommends fresh decisions on brand new situations, and keeps a living memory of every recommendation it's ever made, tracking each one all the way until it's fully resolved. That second part is what took the real engineering work, and that's what I really want to show you today. So let's start with the learning part because it's genuinely a cool technique called offline reinforcement learning. So here's the intuition. Normal reinforcement learning, the kind you see with robots or game playing AI, learns by trying things in the real world and seeing what happens, like trying an action, getting a reward, adjusting, repeating millions of times. Obviously, you cannot do that with real business. You can let an AI take a few thousand random purchase orders just to see what happens and hope it eventually learns the right quantity. So instead, this thing entirely learns offline from logs, every past situation, every decision a human actually made, and the outcome that decision produced. The algorithm, it's called implicit Q-learning or IQL for short. It looks at all of that and essentially asks across everything that's ever happened, which decision stands to produce the best outcome, and can I turn that into a policy I can apply to new situations I haven't seen yet. So no live experimentation, no risk to real inventory or no real customers while it's learning, just pattern recognition on history. So this whole thing is built on as two pieces that hands off to each other. The first is training, that what I just described. Feed it historical real data, it builds an agent and it produces this really satisfying comparison report. Here's what the team actually decided in the past. Here's what the trained agent would have decided instead. And here's exactly how much better or worse it calls would have scored. That part is done, tested and working. The second piece is where I've been spending basically all of my time lately. The production loop. This is the part that takes a trained agent and actually puts it to work every single day on live data. So quick tour of how the training works because I think the pipeline is generally elegant. It consolidates all the relevant historical table into one clean data set, scores every record using record rules, the reward rules that reflect what the business actually considers a good outcome, lets the agent learn the relationship between situations and the actions that historically scored well, and then the fun part. It replaces the trained agent against exact same history and compares its call to what the system actually decided. And that comparison is the report I mentioned. So here's the genuinely interesting engineering wrinkle, and if you're technical, the next bit's for you. The data pipeline for all of this runs on a distributed engine. Think Spark. So processing data across a whole cluster of machines in parallel. But the reinforcement learning library only knows how to train inside a single Python process. It has zero concept of distributed. So it just wants one big pile of data sitting in memory on one machine. So if you can just drop the training step into distributed engine and expect it to work. So the pattern I decided up using, keep the data loading and joining fully distributed. Let the cluster do what it's good at, and then right before the training starts, funnel everything down into a single partition and hand it to one dedicated Python worker. That worker does the actual model training. and the results from follow back out into the distributed world afterward, distributed in single machine train in the middle and distributed out. On top of that, this whole pipeline was actually migrated from an older pandas based version into this new distributed pattern, which meant that every piece of training math business logic had to be diffed line by line against the old system before cutover, because the last thing you want is a subtle bug where the smarter and faster version quietly recommends something slightly different than the old one for no reasons nobody can explain. Okay, so this is the part that I actually want to spend the most time on, because it's what I've been building most recently, and honestly, it's a more interesting problem than training ever was. So here's the situation. Once you have trained an agent, running it once isn't enough. It needs to run every single day forever, and it needs to do two completely different jobs at the same time. Job one is to look at brand new situation that showed up in the day to day and that nobody has ever recommended on before, and generate a fresh recommendation for each one. And job 2, this is the one people don't think about. Go back and check on every recommendation that's still open from the previous day. Did a human approve it yet? Did they change the number? Has the downstream system actually acted on it? Has the order actually got landed? So I think of these as stream A and stream B. Every day both stream run, and they both merge into one output, stamped with today's state, ready for tomorrow's run to pick up where it left off. And the second stream only works because every recommendation carries a status that moves through a specific life cycle. It starts at pending approval, literally just sitting there, waiting for a human. Once someone approves it, maybe with an edit number, it becomes approved. Pending execution means the downstream system hasn't picked it up yet. Once the system acts on it, it flips onto in flight. And once the action is fully completed, stock actually arrives and the order is fully closed, it becomes completed. End of the line. So there are exits along the way too. A human can reject a recommendation outright. A row can time out if nothing happens to it for too long, and the source data goes missing. It gets flashed as stale instead of silently disappearing. So nothing falls through the cracks and nothing gets recommended twice while it's still open. So let me make this concrete. Say the agent at a product and recommends reordering 500 units. Day one, that recommendation just sits there, pending. Day two, a human reviews it and approves 400 instead of 500. Maybe they know something the model doesn't, and that's fine. That's the whole point of keeping a human in the loop. Day three, the purchase order actually gets created downstream, so the status flips to in-flight. Day four, the stock physically appears and the recommendation closes out as completed. The interesting part, the agent's original number, that 500, never changes after day one. It's a historical record, but the status dropped out around it. It keeps evolving every day until the story is actually over. So now if you build something real, the model itself is rarely the hard part. It's everything around it. A few honest war stories. But at one point, a subtle bug lets date filter get silently disabled, which meant a join across multiple tables just kept growing unbounded day after day until it ran out of memory and crashed in production. The fix was boring but necessary, a hard row count that fails loudly instead of quietly exploding, plus a rolling date window specifically for the daily run. Separately, a deployment pipeline started running out of disk space because the machine learning library's default dependency pulled in several GBs of CPU flavored packages. This build didn't even need. So I had to slim that down mid build just to get the container to finish. And there was a fun one where a hard dependency of the training library simply didn't ship a pre-built package for any Python version in use. So the build had to be told explicitly to compile it from source instead. But none of it's glamorous, but it's the actual job, right? So stepping back, why does any of this actually matter? So three things. First, no duplicate actions. Because the system always knows what's already in flight, it will never re-recommend on something that's still being handled. Second, every human correction becomes structured data every time a person overrides the agent's number that gets captured and feeds the next training cycle. So the agent should get closer to what people approve over time. And third, one single source of truth for status instead of people manually tracking spreadsheets. That's one clean answer to where the system right now for every recommendation all the time. So right now, the training and full predict flow are both built, tested end to end, and all three use cases are actually built and approved at this point. The plan now is to roll all three into full production, running the exact same daily pattern at scale. So if you are building anything like this, like offline RL, production ML pipelines, Spark plus Python hybrids, I genuinely love to hear about how you are tackling it. Drop it in the comments, and if this was genuinely useful, subscribe, because I'm generally planning to go deeper into predict flow and status stage management in a follow-up video. Thanks for watching, and I'll see you in the next one.